It's actually recording. Hello, everybody. Today is the 27th of September. This is Dallas Personal Robotics Group Robot Builders Night Online. And we'll just do the usual thing, go around the table, talk about robot-y things, things related to software, mechatronics, and the usual show and tell, questions for the group, whatever else makes sense. Just housekeeping, have a screenshot for this meeting. Nothing changing on the left-hand side. And we're all looking forward, I hope, to the 12th of November, coming up in just a month and a half. And we're going to meet out at a special location and have a Robo Columbus contest running. And John G., I think you did put your Raspberry Pi hat out on the website, and maybe Doug has some questions on that.
Doug added that. I just gave him access to the GitHub.
Okay. All right. And then if there are any ideas anyone had, we could add those to the rolling list for monthly meetings. Okay. Hearing nothing, we can come back to it if someone has an idea. So with that in mind, the queue we have tonight so far is Ray, and then Doug P. has a question for someone who's not here yet, but he also has a show and tell opportunity. So after that, it's a free-for-all. So Ray, let's take it away.
Okay. All right. In my quest for other perfect sensors, I bought a radar sensor. It is the FM24-NP100, and it seems like there's several variations of this, some that provide kind of the multiple distances, and what they're referring to as the spectral lines are supposed to be like 126, I think, spectral lines that indicate basically where the peak reflectivity is. Anyway, so and I was just looking for some Arduino code to test it out, and assuming it had a certain output, like there's a pin here that says you can get like just a single output, the closest one, or multiple outputs. And this version doesn't do anything. It's all multiple outputs. Anyway, screen. Whoop. Here it is. Share. Okay, can you see that Arduino program?
Mm-hmm.
Okay. Anyway, I actually got this from DF Robot, assuming that it was set up for, another way, and actually it's not set up like that at all. So this one will output up to 5 measurement readings, and it sends basically an ASCII string, like a number, like say 1, a colon, and then what the distance is for that measurement, and then 2, colon, another measurement, and so on down to 5. And so you more or less have to parse that. So what I was doing is looking for, I think, what is 0A, a carriage return or line feed? I always forget which one's which. Carriage return, I think it's the line feed. So when I have that, that's indicated it's the end of that little string. And so I'm looking for, the number 1, 2, 3, 4, 5 in it. Once I find it, those should probably be zeros, but I just put them 0A. And then on the remainder of the string, I do an ASCII to integer conversion and store up to 5 distances if I have it. Zero out the flags, zero out the the counter that goes through the string. Print out the results, and again, this is another thing that's kind of threw together. I put the null character in for all the readings of the buffer. And the other part of the loop is, yeah, if the character read is carriage return, then do all those things. Otherwise, stick the character that I just read into the buffer, increment basically the J or the index value. And if it's equal to or greater than 8, put it back to 0. And that's kind of the whole function. Anyway, I'm going to plug it in. And tools. Serial monitor, it's just, I don't know if you can see that or if it's just blur.
Looks good.
Looks good, yeah.
Okay, so distance 1 is 209 centimeters, distance 2, roughly 280, distance 3, 380, and distance 4. It looks like there is no distance 5. And this is, it's not in ideal conditions. There's all kinds of things to reflect off of. It's got a 78-degree, I think, field of view horizontally and only a 30-degree view vertically. So it's pretty narrow. Anyway, so if I stick my hand out here, distance 1 reduces quite a bit. And it's a little easier to see it if you go to plotter mode. I don't know if you can see those little wiggly lines on there.
Oh yeah.
Mhm, mhm.
Yeah. Okay.
Yeah.
So anyway, the green one on the bottom, I'm standing in front of it and walking backwards. So it should get bigger and bigger.
Yep.
Anyway, and then moving forward, I don't know, maybe 2 meters away. So, well, no, a little more than 2 meters, around 2 meters though. And then coming back towards it. Anyway, so it seems to indicate distance is pretty good. Don't have to worry about varying light conditions, wind, humidity.
What's the sensor you're using?
It's the FM24-NP100.
I put a link that I found from Newegg in the chat.
Which is what, a LiDAR sensor?
A radar sensor. It's a
Oh,
20.
it's real radar?
Yeah, 25 gigahertz radar.
Ooh.
Anyway, looks interesting. It doesn't tell you, an angle, what that distance is. But if you're, 78 degrees in front of your robot or your platform, if something is, 50 centimeters away, then you're probably going to run into it.
Hey, Ray,
Yeah.
A while back, they introduced some radar sensors that were really sensitive to detecting people.
Yeah.
Okay. But they weren't very useful for anything else.
Mm-hmm.
If you take take a cardboard box and wave it in front of it,
Oh, okay.
does it change?
Let's experiment.
I was wondering if it could recognize a chain link fence wire.
Probably not a chain link. Well, I don't know. It might reflect really weird off a chain link fence. Of course, it's hard to say whether this is going to pick up off on my arm or not. Okay. Looks like it is picking it up. There's a lot of metallic objects in this room, so I may be getting reflections everywhere.
Well, that what I'm saying, that would be something if you're experimenting with it and you take it outdoors, I'd like to see if you could, you put a target on a stick or something and wave it in front of it and see if it changes it.
Yeah.
Yeah. What if you just get up? Hey, do that, Ray. Hey, Ray.
Yeah.
Get behind it. Stand behind it
Mhm.
They just hold the box in front of it, say
Oh,
about
okay.
as far as your arm length is.
All right.
That's
Okay.
what I wanted to know, is
Front of
if
it.
it'll sense something behind the sensor itself.
Well,
No,
but
it
that
shouldn't.
gets another question. So it's not like light, right? Probably it's probably not a forward-looking only cone. It's probably got a lobe with back lobes, right?
Yeah. Well,
So-
what I'm trying to say is it doesn't look sensitive to objects. That I'm seeing, it would seem like it's more sensitive to people. And
To
I don't,
people, yeah.
I'm not sure why the other one, I'm sure you've got the guy with the Swiss accent. He had a whole big spill about these 50 cent or $1 at the time. I'm sure they're $6 now.
Yeah.
Sensors that, they were good, really good for putting in a room, and they acted like a PIR sensor basically
Yeah.
in function. They didn't work on the same principle. They worked on a radar, but for some reason they were able to detect people really good, but
Yeah.
non-people that wasn't that detective. Anyway, that'd be something to experiment with to see.
Yeah, it probably has something to do with the wavelength of the radar. So, if it's a wavelength that absorbs water or something.
Yeah, I was thinking that too.
Yeah.
Ted.
Or is reflected, or water reflects it or something.
Yeah.
Yeah.
And something like a chain link fence, if the wavelength's too small, the waves will go right through the fence, the holes in it.
Yeah, that's true. I know some of the shielding stuff, it used to, it had to be a certain size hole to kind of keep the EMI trapped in the box. If it got
What's
too big,
the,
it could escape.
What's the maximum practical range on that unit?
They say it's 20 meters. I haven't brought it outside yet to find out if it can see cones. I mean, that's what I was thinking it would be good for. But
Yeah.
anyway,
So, Ray, is the first number reported, first target always the shortest distance?
as far as I can tell, yeah,
Okay.
there's not very great documentation on these. But
It'd be nice to know if you could get an angle out of that somehow. That would be,
Yeah.
that would make it the cat's meow.
Yeah, the only way I think you could get it is if, it was on, say, the sides of the detection area,
Mhm.
and you either moved a little bit left or a little bit right to get the object out of the field of view.
Yeah.
And then you'd know, if you're moving left and it disappears, it was to your right,
Yeah.
and vice versa. So,
Mhm.
but yeah, I just wanted to, experiment with one and see. Hopefully,
Good deal.
I won't be disappointed once I get out there and just point it at cones if it doesn't detect cones. So,
Yeah.
but yeah, I think human presence is, one of the big uses of it. But
Yeah.
this one was supposed to be for objects. So,
Okay. So there's hope.
yeah.
Okay, cool.
Anyway,
Can you fill the cone with water?
yeah. Hey, there's an idea. Put a water bag on it or in it or something.
Got to hold it down, right?
That's right. Weight needs a little weight. Anyway, that was all I had.
Well, that's pretty cool. And if you had any links on the documentation and such, that'd be cool to put in here just so we could read up on what you showed us.
Okay. I'll look for one. I know RF Bros has one,
All right.
but it's pretty scant. Yeah, from what I can gather, maybe two brothers who are interested in RF circuitry and components from China. I don't know. RF Bros, that's who you go to.
That sounds really funny. It's like
But,
find historical artifacts, bros.
Bros, yeah.
Those things just don't go together, do they?
No, not really.
Yeah.
I'll look here. RF.
Okay. Well, cool. I know Doug has a question, but we're trying to hold off till hopefully Scott joins. So does anyone have something they want to sneak in before Doug? Then maybe Doug, you want to jump in with your?
Yeah. Okay. Maybe somebody will be able to help me.
Well, start off with your demo, your show and tell. Maybe.
Oh, okay. Well,
yeah.
My robot is starting to come together, which it should because we got 6 weeks. You can see I've got the GPS hooked up. Here's the IMU, the Oak D light. Here's my Pi. Here's the actual GPS unit. This is the board that was given to me by John G. And I'm going to start off using Arduino because of my time. And there's a couple of problems I have. Okay, so the real problem I have is that the GPS is I squared C. The IMU is I squared C. The two servos are I squared C because they're going through that little 16 breakout there. So the real problem I've got is I got to figure out how I want to wire all my I squared C stuff. And then, so I started saying, well, all right, to go up here to down here is quite a distance for I don't know if I did that right. Up here to down here is quite a distance for me on I squared C. I know other people have done things like that, but so I'm really interested in I squared C wiring. And I found a thing. I'm going to share something now and see, and then talk about what I've done as a first pass.
Hey, Doug, did you know that Adafruit sells some pretty long, quick cables?
No, that's an idea. But what I decided to do was, this is NXP Semiconductors, what do they call it? It's application note. And they're using essentially Cat 5, I believe, Cat 5 wiring. And they are using boosters, but the idea of the wiring should be about the same. So if you look at this diagram, I don't know if I can make it bigger. Does that make it any better to see? I can't see this. Okay.
Yeah.
All right. So what they do, you have in Cat 5 or 6, you have four 2-wire twisted pairs, okay? Or 8 wires total. So what they're doing is they're bringing over the twisted pair for the 5 volts completely tied together. And they're doing the same thing with the ground. So that takes 2 of your twisted pairs. And then for SDA, they're taking the third twisted pair and they're running 1 wire to the SDA, and the other portion of the twisted pair, they're running up to 5 volts. And for the clock, they're tying one of the twisted pairs to the clock and the other one to ground. So you essentially have 3 wires out of your 8 that go to ground and 3 wires go to 5 volts, and then 1 to each of the 2 SDA and SDI. So I wired up a piece of Cat 5 to do that. And I can tell you, I'm still screwing around with how to terminate that. But I have managed to get 1 wire completely, from the IMU down. Now, following the same idea, I took the 4 wires that come in the little. I don't know if I've got one here. Why am I not?
So I can't think of the
So-
name of him, but
All right,
our
so
knife grinder guy that had his bat or whatever hurt.
yeah, John G.
I muted him.
Okay.
I muted you, John.
All right. So anyway, these little cables that you get, the one that Ray just mentioned, this one happens to have DuPonts on the end, but you can get all various
Quick
combinations.
connectors on the end.
Yeah. So, so what I decided to try, at least to keep in the spirit of this, is I've divided it, the ground and the clock and the 5 volts and the SDA, and twisted these around each other, just like this, and tied them down so they don't untwist. And I'm using that to continue on. And then this plugs into a Cat 5 cable that's terminated in a really weird way. So I'm not saying this is the right way to do it, but if you look real close here, you can see I've got it terminated over here. That was a pain in the butt. And I don't
With
think-
resistors or something, or
no resistors, just wire. Just the attempt to keep the twisted pairs continuous through the whole thing. So the question I have is this, am I interpreting this correctly? Or what are other people doing? What have other people done and it didn't work? Any of those type of stories I really like to hear, because
What speed are you planning to run?
I want to say I think it's 400
kilohertz.
400K, I believe is the standard speed.
Do you
Not
need that
100K,
much speed? Could you
so-
run at 100K?
I don't know.
That's the slower speed.
Yeah, I don't know how configurable the different I2C.
So one end is your Raspberry
Close.
Pi, and the other end's your slave device?
No, that could be one way. And like I say, I'm still trying to decide what device I want to run on what thing. One way would be to put everything on I2 on the Pi. That's doable. Or you can split it up and put some of them. Since I already have pretty good code base for Arduino, I could put some of them on Arduino, and some of them. The only thing that's really set in stone is the Oak Delight has to be on the Pi. Okay.
My experience with I2C, and I've done this with many different devices connected to the Pi,
Mhm.
is first off, the Raspberry Pi does not provide its own pull-ups. So you have to add pull-ups
Okay.
to pull the SCL and SDA lines up to when there's nobody asserting anything on the bus.
Mhm.
And the other issue I have is usually I can't get away with running at like 150K baud. I usually drop it. I can run at that, but you have to tolerate, you'll see 1-bit errors once in a while.
Mhm.
I found that when talking from the Raspberry Pi to a device over I2C, I usually drop it down to 40K baud to eliminate all the bit errors that you get in the transmission. But
But John,
that's
so-
using like, a very short jumper wires from
Yeah.
the Pi to the.
But a lot of that, I believe, is due to the Pi's problems with pulse stretching, and that's what makes it kind of unideal for that.
Yeah, the Pi does not clock stretch.
but
Yeah.
also, John, do you, when you talk about using short jumper wires, how short, and do you make any attempt to twist them with a low impedance something?
I haven't tried twisting them. And when I say short wires, we're talking about typically 6 inches. Sometimes, I'll go a little bit longer than that, maybe a foot.
Mhm.
So Doug has longer dimensions than that, right? But I'll tell you
Yeah.
from if I dust off my EMC double E kind of background stuff and look at this, what I like is that if you look at that diagram, Doug,
Yeah.
you'll see that first of all, one of the tricks is that ground isn't the only low impedance thing you can use as a plane.
Yeah.
+5 is also a good low impedance thing. So what they've done, which I like a lot, is that they have like 2 wires just dedicated for the +5, 2 wires for the ground. So that should help with resistive loss, right? Those 2 wires twisted together.
Yeah.
But then the important thing is that gives you a nice, hopefully clean supply to the other end. But then the other thing that that calls to my attention is on SDA and SCL, those data and clock lines, they each have their own low impedance twisted pair. So in other words, the SDA in here is twisted with 5 volts, and the SCL is twisted with ground.
Right.
So what that does is it gives a nice for any like radiated susceptibility coming, any fields that might otherwise couple into untwisted pair, because it's twisted, that will, and with a low impedance return, that'll help keep noise from irradiated noise from coupling in to that line.
Yeah. I mean, I definitely think it's an improvement, but I just wondered if anybody had, I mean, I guess in another week I'll know, you know what I mean? But the question is, I'm just hoping that somebody could say, well, yeah, we did that. And that, I guess a subset of this one is how do you best terminate? So I got 8 wires, all right? And I have 4 wires over here. So, you know, obviously 3 and 3 and 1 and 1, and they go into the other 4. But what kind of connector? You know, I just took a piece of I don't know, what do they call this stuff?
Blob board?
Yeah, you know, the things like this.
That's what I would do. Is that?
Yeah, you know, like this. This one's a long one, and I just stuck it in. But you know, maybe a piece of this is where a piece of breadboard, you know, just old-fashioned prototype breadboard, might be set up and do it that way. I don't know.
I was going to say you got your ink toner cartridge PCB methodology. You could just make yourself some generic termination adapters.
Oh yeah, or that's simple enough. You could even just pull out a piece of, you know, like strip board or something like that and do it.
Yeah, one of the things I2C is very sensitive to is stray capacitance. If you look at the spec,
Yeah.
if you're going to run at speeds anywhere between 100 kilobits and 400 kilobits, your maximum capacitance of your line is only 400 picofarads.
Yeah, but that's part of that's what they're doing here. You know, one of the things they're doing here is they're using this really thin wire, and that's what E5 is, and E6, Cat 5, Cat 6. You know, that's their claim to fame. They're about as low capacitance per square foot, per linear foot as you can get, I believe.
So do you know this offhand? I mean, is it compatible? That's the nice part about these Cat 5 lines, right? Because as opposed to where we used to take wire and a drill and make our own twisted pair, Cat 5 and 6 is made to a spec.
Yeah.
So we ought to be able to look up, like you say, the capacitance.
Yeah, it's real. I want to say it's really low. It's
Every pair has different twists per foot.
Yeah, that's
on
true.
the Cat 6. And you look at their spec, you can run it for Ethernet cable, 305 feet, I believe.
Yeah, about 100 yards.
Yeah, but Ethernet, I think is I think it's using like a differential current loop. So that's one of the big differences here, right? Because this, like the schematic on this I2C, this is meant for inter-chip communication, right? Board to board.
Yeah.
It's a voltage level signal. But when you get into these long, these 100-foot, 1,000-foot long runs, what they'll do is they'll take the voltage signal and put it into a current source. So they're modulating the current through the loop, not the voltage. And by doing that, they're able to greatly improve the ability to overcome stray capacitance and reduce susceptibility to coupled in noise.
Mhm.
So Doug, are you planning to put extra drivers in, like I saw in that circuit, or are you planning?
Hoping not to.
Okay, so ribbon cable, for example,
Yeah.
the old-fashioned ribbon cable,
Hmm.
every other pin is ground. Every other pin is ground.
Yeah.
On the original, with the
Yeah.
way they were used.
Hmm.
So if the first pin is ground and then you ran a signal, and the second pin is ground and you ran a signal, the third pin is ground, you run a signal, you get a double. It's a really compact, small thing. Now, it doesn't work against high magnetic fields, but it works pretty well as shielding.
Hmm.
It's a poor man's
Yeah.
way of doing the exact thing. It's
That
not-
was my other alternative. I was looking at that, Bob, because I thought, I got tons of old computer cables and stuff. I could easily rig up something like that. And
I found that to work super well when
Yeah.
noise was critical.
yeah,
Now, not perfect, but
yeah,
you don't need perfect, you need digital.
yeah.
So it's probably going to work, just work.
Well, we'll see. Like I say, if this works, then I haven't looked up those chips to see how expensive or if they're pre-made. Where you can buy them just little modules where you can
They're
just
little differential chips. I've used them on
Yeah.
circuit boards. And interconnections between circuit boards at 8 megahertz.
Mhm.
And reflections would happen, and you had to deal with that. And you had to look at it with an oscilloscope to
Mhm.
see if there were any reflections. But
Mhm.
you're not running at that speed,
No.
especially if you don't have any drivers.
Yeah.
So it shouldn't be an issue.
Well, that's what I'm
long
hoping.
Well, as long as you have an oscilloscope to hook up,
Yeah.
you should be able to tell if there's an issue or not. Just turn your
Yeah.
motors on and your other stuff on when you're testing it.
Yeah.
Yeah.
And one of the things,
Yeah.
yeah, that's true too. Like I say, I guess I'll know next week. It'll be
Yeah.
either a big failure or,
No, it'll looks like it'll work.
yeah. Okay,
It'll
that's
it'll
good.
for sure work. It's just a lot of. I would personally, I would just start with the ribbon cable and see if it worked
Yeah. Okay.
without an issue, because every other shielded wire works pretty well.
Yeah. Okay.
Poor man's shield.
Okay. Sounds good. Anybody else got any inputs? That would be.
What's the ribbon cable capacitance typically? Any idea?
I don't know.
There's two, and there's different ribbon cables too. Do you remember back when I'm dating myself here. Back when we were running 8086s,
Oh yeah.
and they had their drive cable. And then somewhere when they went up, I think it was 84, 86 or something like that, they suddenly changed the standard and they went to a real fine ribbon cable. You remember that? And I'm
I
sure
remember the
that
one before it, but not that one. Yeah.
Okay, well, anyway, that's probably that. That's probably for capacitance reasons. So when the bus speeds got faster enough, they couldn't use the old-fashioned ribbon cable. And they went to the slick. If you ever saw it, it was real fine. It was definitely different than the old thick wire ribbon cable.
Right.
Yeah.
So Doug, well, the talk's been going on. We've got some interesting napkin analysis going on in the chat.
Oh, okay, I haven't been looking at you. Let me see.
It's comparing the 400 puff limit of the I2C spec with the straight capacitance or of per foot of different kinds of cables.
Mm-hmm.
So it looks like either the ribbon cable or the this Cat5 is likely to work for you.
Okay, that's
And
good.
Personally, I like the idea someone brought up too of getting a scope, because at the end of the day, right, it's the to me the issue is not really the cycle time of how many bits per second. It's actually the real issue is the rise time and fall time of the signal, because that's that's like a broadband step function.
Mhm.
And when that thing enters this transmission line, it's going to ring and bounce and reflect all over the place. So I suspect that taking care in how you transition from the cable to the circuit card at either end can have a noticeable impact on how well it works. But I think also that you'll be able to tell that with a scope, like someone mentioned, right? Because scopes only at 10 or 15 puff. So you should be able to look at that, and if you see ringing and reflections that are down near the, then you'll know that it's just not going to work.
Yeah. The other thing too, that's, a real simple one is, like Bob said, is just turn everything on and you just watch your output. And if your output freezes or your output just suddenly stops working, that's, or you
Sure.
misses every other one or something like that, depending on how robust their I2C routines are.
Yeah.
We'll see. But, basically, I got it. For my robot to work, the GPS has got to work, but that's a small one. That's not a very long line. So I'm not too worried about that. I'm more worried about the IMU. And that one, like I say, there's no real good way to make that short. And so we'll see. We'll see how it goes. And if it all works out, hey, great.
Well, my last vote. You've got a really nice scope. I would love to see the trace after you do this.
Okay. Yeah, that I have a wrangle, so it's easy to do. I just put it. That's when you really see the advantage of the new scopes. You just pick it up and put it where you want it and get your signal, as opposed to hauling around, trying to find desk space and all that other good stuff. So, yeah. All right. So anyway, that sounds good. And I'm planning on using these to distribute power. These are the Hobby Wing UBEX. I've had a lot of good luck with these guys. So right now I got a couple, and I got plenty, but I'm using these, and I'm putting those little red leads on them. I don't know, you know.
Oh yeah.
Yeah. So this hooks into that adapter I showed a couple weeks ago, and then so I'll have one for the Arduino type stuff, and one for the servos, and probably one. I'm thinking of using. Well, okay, it'll either be for the ultrasonics if I go that way, or if I use the Benny Wake Mini, I think it is called the Benny Wake Mini. If I use that LiDAR, I might keep it on the Arduino line. So we'll see. And I'm using an OtterBox, battery unit that's mounted underneath that platform. Just slips right in and use that. And that's where the Pi is totally isolated, except for the ground line, obviously. So we'll see how it goes. Trying to get power down. I've actually have used one of these to power a Raspberry Pi 4. And it's when you really load up the Pi, this thing is like spec'd at 3 amps. So when you really pull in 3 amps on the Pi, this guy's kind of on the edge.
What is that?
That's that UBEC I was showing.
Your universal battery eliminator circuit. From the
Let's see if I can get it to focus. But it's Hobby Wing.
Hobby Wing.
Yeah. And if you're shopping for these, you need to look around because there are places where you can buy them as cheap as $4 or $5 and other places where you pay $15 for it. So you just have to check.
Could you link that in chat where you found that?
Sure. Let's see. Okay, I'll do that. So I'm going to drop off and get that taken care of. Let's see.
Oh, cool. So what else we got? So just a question, show of hands here for those people online. How many are planning to do something for Robo Columbus? That's pretty good, right? Maybe. Pat, weren't you going to do something, Pat, or did you already?
No, I did not. Fall came up pretty quick. Leaves are changing colors here today. I ended up having to go about, about 15 miles away, and there's an awful lot of orange in the bush. So I didn't have time to get everything going, so I'll continue working throughout the winter on this.
Bummer.
And
Okay.
hopefully have something ready for next year that I don't have to scramble at the end of the season, and then mid-September I can video a run and be ready.
Well, that sounds good. I'm kind of on your schedule too, I think, for whatever that's worth.
Yeah, life interfered with robots this I guess late summer.
Yeah, same. So
I've kind of had the same issues where things have interfered and life's gotten busy. And also, November's not a great time for me to be driving down to Dallas. So I'd rather just drive than try to do it remotely.
Yeah.
There's a consideration for next year. The drivability. And is that a weather thing?
No, it's just kind of busy with family and
Holiday times.
Thanksgiving coming up, and
that's always our challenge here is you got the blazing hot summer when there's a little more flexibility to travel, but then when it's cooler, then all these holidays. So
yeah,
it's hard to find just the right thing.
Well, all in all, I think after experiencing August in Texas, I'd rather do the cooler and figure out how to travel.
Give you an idea, it was about 50 degrees here today, 50 degrees F.
Okay.
So not very, it's a little cooler than normal.
I think it got up to 90 here where I live. So.
Oh, yeah, it was beautiful though, right? Because when I went on my bike ride, it was 84, but the humidity was only 24%.
Mm-hmm.
So it's not often when the feels like is less than the actual. But that just was really nice. I wish it was more like that more often. All right. Well, maybe I'll jump in while we see who else wants to chat. So I'm in the similar boat as others, where life got in the way and not really a chance to do anything new like I'd hoped to. So instead, what I'm going to do is take the robot I ran last year, but with much improved software. So the mechanics will still really struggle with grass and torque, but if we put the cones on the street, it'll work pretty good. So I'm going to now.
Carl, you're going to refresh the duct tape.
Yeah, the duct tape might be showing its age after a year as well.
Maybe.
The baling wire is still holding in. So that was the name of it: duct tape and baling wire.
So if you do it in the street, will you have like the survival challenge where you have to dodge cars?
Exactly.
Your object detection goes, car, you know, and squish.
It'll go from duct tape and baling wire to flat. We'll call it the flat robot.
Okay, yeah.
But anyhow, that's my update week as
Yeah.
it is.
I'm hoping that next week, with a little luck, I might have something I can show up front. Either it driving to a cone, or
Yeah.
that's what I'm hoping to have next week. So we'll see.
That'll be good. We get us a star on this. On one of
Yeah.
these. Yeah.
I did update my little. I don't know. It's like I think I'm going to call it the tricorder. You know, I think I'm going to strap it to my wrist. It's kind of the state of the robot. So it's like, you know, the state of the calibration of the B&O 055, what the current heading is, what the target heading is, what the encoder counts are, what target counts might be. Oh yeah, which function I'm in. I added that recently. What else? Target heading. Oh yeah, the latitude and longitude, the quality of the fix, and all those things. So this is kind of nice. There's ESP now is a protocol that you can use to send whatever you want. This is actually a structure of all these different variables that you send over, and it's a lot easier to look at this and carry this around independent of the robot than to look at this little teeny OLED display that's moving on the thing in very
Yeah.
bright light. So
Right. Yeah.
so it's big enough to, I made the text big enough to see. I can see it outdoors in bright light. So it's kind of neat, very portable. I just have it powered with a battery, power pack right now. But,
Okay, Ray, you brought up, and I got another question for people. All right, usually when I'm using the BNO 055 in the past, I haven't used the compass because just wasn't necessary for what I was doing.
Yep.
So here it is, because I want to know, robot's position in the world. The question I have, are you guys calibrating your compass ahead of time and storing the units in there, or are you allowing it? Because I read somewhere on Adafruit that it will self-calibrate after a certain amount of movement. I was just curious, what you're calibrating it ahead of time, storing the values?
Yeah, I do. I calibrate and store the baseline values.
Okay.
And then anytime it's running, it's auto. I don't know if there's any way to turn off the auto calibration.
Yeah.
But what you do by storing it is that you give it initial starting point, so it
Didn't have to find it.
it doesn't take as long to settle in.
Okay.
Yeah, one
Yeah.
thing to watch out for while it's settling in, you'll get values that are way off before it actually finds north.
Mm-hmm. So you can avoid that, Ted, by giving it starting values, or
Yeah, that helps. And then I just like to hold it and spin it around a couple times and then set it down so it calibrates faster that way.
gotcha.
Yeah, I saw a video. You could hold it at like a 45 and then a 90, and then in each of roll, pitch, and yaw, and it seems to calibrate pretty quick and stay at like the level 3, which is the best calibration you can get. So
Yeah. I used to do that. You get bigger the robot is, the harder it is.
Yeah.
I used to do it this way, where you would roll it completely around and completely around, and then whatever the other direction is, I guess like this.
So it's, let's see, roll I think is this way, like a ship rolling side to side. Pitch is up and down, and yaw is
around,
left and right. Yeah.
Okay. Okay. Good input.
I was tempted to make some folding not a gimbal, but a folding contraption so that you could push a button and it would automatically just move it to each of the different dimensions. And
Yeah. Do you guys calibrate your accelerometer ahead of time? You know.
Well, that movement is supposed to calibrate all
Oh.
three.
yeah.
Yeah.
Okay, got it. Okay.
And that's one of the things that I spit out on the top, the calibration for the gyro, for the magnetometer, for the accelerometer, and the system. You know, there's a system one you can look at, but I think you just really need to look at the other three. So,
Okay,
But-
cool.
Hey Doug, would you mind posting a link to that circuit diagram you showed from the
Oh,
end?
yeah, yeah.
Right.
Okay.
Um,
Let me get that.
Because I've always been puzzled about the use of twisted pairs where, in combination with single-ended signals, and that's what's being done here. And I found a Stack Exchange article that talks about how that can be beneficial, but under certain circumstances. And I'm trying to understand whether those circumstances are met in this case.
I kind of thought, you know, the rule of thumb was you wanted the source, the line, and the load to have, you know, similar impedance. And if you didn't, you could get reflections or standing waves, basically, if you have like a continuous train.
But the impedance is frequency sensitive, right? And
Yeah.
the frequency, like I mentioned, the frequencies we're concerned about are, I mean, obviously the duty cycle of the data signal, but I think for these kinds of things, what really gets you is the bandwidth of the rise time and fall time of the data signal.
Yeah.
So I think it wants to have a nice square pulse, and as soon as you give it a cable, it's going to start to go like this.
Right.
And if there's reflections, then you're going to, I mean, if it's not terminated well, at the rise time and fall time frequencies, if the cable has the wrong impedance, then that signal is going to come up, it's going to hit the termination, it's going to bounce off, and you're going to get ringing.
Yeah.
Okay, couple of questions that brings up, Carl. All right. Like Paul said, he had questions about this, and one of the questions I have is when you throw in a shield. Okay, this doesn't have a foil shield or anything.
Right.
I know you don't. I know that you'll get a ground loop if you ground both ends of the shield. So, you know, there's a bunch of stuff there that I've always been a little hazy on. And, you know, like I've read where it's better to ground the input end of your cable as opposed to the output, and all these things that I've read, but I've never actually worked with any of it. And I'd love to find somebody who could tell me kind of what was going on there. The other thing though was, all right, so let's say I put my scope on there and I do see the reflections. All right, now from what I've read on I2C, what they would tell you, you can help that by tuning your pull-up resistor. Otherwise, the pull-up resistor you use, the value of it can change. And I assume that's changing changing either input or output impedance. I don't know which one, but it's going to be changing some impedance. So a question I had is that how you would terminate a line like that, or are you actually putting a resistor across the two lines?
Unfortunately,
For differential, usually it's you know, across the two lines, but if these are just pull-ups to VCC
Yeah.
on I2C.
Yeah.
So, yeah.
but across or pull up or pull down, and in a way it doesn't matter, right? Because you're just adding resistive load to the end.
Yeah.
Yeah.
So and this is where I'm afraid I'm just too far rusty on it. But there's if you look at the circuit, what's going on, and from a transmission line mindset versus
Mm-hmm.
you've really got a distributed LCR.
Right.
So,
You've got inductance per foot, you've got capacitance per foot, and you've got resistance per foot.
yeah,
And they're distributed along the whole way. And then, in a Cat5 cable or a shielded cable, it's well controlled and it doesn't vary much until you hit the termination, right?
yeah,
So then when you hit the termination, now you go from the one resistance to another, and then all of a sudden this traveling wave comes down and it goes, whoa, some fraction of it will bounce back. So the power won't go into the load. It'll head back down the line towards the source, and you wind up with a ring.
yeah. So that's what I'm saying. So how do you get rid of the ring if you've got it?
Well, I think
Let me
just with the LCR thinking, I mean, you got those three parameters. So maybe the resistor can help in one way. Maybe mucking around with tuning capacitors and inductors is another way. But of course, it's easier to find lots of different values of resistors than capacitors or inductors. So I suspect that's why you wind up tending to tune these with resistors.
You do tune them with resistors. You also, the scope has to be at each end grounded with a
Yeah.
short ground lead. So when you're connected and looking at one end, make sure the scope probe and the ground connection are close to your connection. So you have to do that on both ends, because you'll see a ring sometimes just from your scope.
Yep.
You have
Okay.
it grounded in one spot and you touch it in another. So that's that loop. You don't want any open loops is the issue.
Yeah.
The
Okay.
ribbon cable gets rid of the open loops because they're side by side. If you just use the little things that come with your Arduino, they're open. That's an open loop. It's an issue even with a short cable many times.
Yeah.
Whereas in a long cable or a Cat5 cable, especially, that's great, right? Yeah.
Mhm.
Even this probe, this is a 10, supposedly a 10 mega ohm probe. It's 13.5 picofarads.
Right.
So that can be, I know in some of the telecommunication data rates, like, the 44 megahertz one, we had to buy special probes, low capacitance probes, because you affect your measurements just by sticking the probe on different points in a circuit.
And everything is times 10.
Well, that's
Yeah.
why you want to use the times 10 mode, not the times one, because the times one loads it down more.
Right.
Yeah.
But the other trick, and I agree completely with you, Bob, that you want to keep that loop. You want to have this ground reference be as close to the thing you're measuring as possible. So the trick that we would often do back when I was doing military electronics was we would have the test points designed so that you could push on whatever you're trying to test, and then you could get a screwdriver. You
Right.
could just,
Yeah.
you could
So
just
they make actually a little spring for that goes on the end of that.
go, yes. The better one. This is a cheapie. The better ones have a spring tip, and then you could just measure it like this.
Yeah.
And
Or
have
you
a
could-
really short loop from the test point to the ground.
Yep.
Yeah.
This is kind of the same thing. It's a socket on one end and a pin on the other. Got it in front of my camera.
There you
And
go.
it is the same distance as the probe head. So basically, you don't have this long ground lead on it. You have this,
Right.
and so those two are about the same length, and that works really well.
So there's
Anyway.
an interesting characteristic of the circuit diagram that Doug showed earlier. It is terminated at the source end, at the master end, I'm sorry, with 300 ohms on the SDA line, but there's no termination on the SCL line. But there is termination of 300 ohms on both at the slave end on both the SCL and SDA lines.
One of the things on that, I don't know, I haven't looked at that circuit in these terms, but a lot of times they have level shifters. And so it'd be on the slave end, because that's where the level shifter usually that's usually where you're trying to control. That's where your pull-ups are usually, from what I've seen by looking at sensors and stuff. And so like if you're having an Arduino at 5 volts and you've got a sensor, with most of the new sensors are 3.2 volts, you've got to have something in there that isolates those 2 voltages. So they usually have pull-ups on the master side, the 5 volt size, and they have pull-ups on the slave side, and then they have a MOSFET in between, which allows you to shift the voltage. And so that might be part of what you're seeing there. I don't know what the voltages are on that diagram. I didn't look for that. But if they change the voltages, then there's somehow I have to achieve a level shifting.
Paul, I think what you've found aligns very much with what I've been saying and what I think Bob mentioned, and that is that you tune it with resistors because the clock signal only goes in the direction from the master to the slave, right?
Yeah.
But the data line can go in both directions.
Yeah.
So if you think about this from a distributed, like the cable is a distributed LC circuit.
Right.
I mean, you throw away, you ignore the resistance. It should be low. It's wire. So you think of the cable as a distributed LC. And then since it's a transmission line, you're launching some RF signal, basically. The step function is so fast. You're launching an RF signal down that transmission line. And what's going to happen when it gets to the other end? Well, if the other end doesn't have any load, it's going to bounce and roll right back a lot of that energy. So what you want to do then is have that 300 ohm termination at the load end so that when you launch the signal down the transmission line, once it gets there, that resistor will help eat up the energy instead of letting it bounce back towards the source. So that's why for the SDA, I think I would bet it more than a Happy Meal and less than a Seasons 52 that this is right. That the SDA has the 300 on both ends because you terminate the end of the transmission line, and the SCL only has it at the slave because you only it's from to the 5 volts, but because you're only transmitting the transmission line in one direction.
Yeah, that makes sense, Carl.
That's cool.
I've got a question on that. So if you look at that circuit, they show a buffer. So in the data line, there's a bidirectional buffer. And in the clock line, I believe it's just a single direction buffer. They show the other one as dotted.
Yeah.
How do you do clock stretching with that? If your device wants to drop the clock low to stretch it out to come up with its values, how do you deal with that for clock stretching?
Well, technically, even the clock line is considered bidirectional precisely because of its clock stretching, right? Because
Yeah.
I think the way clock stretching works is the slave at some point holds the clock line low,
Yeah.
basically
Yeah.
overriding the master.
So in that drawing, they show it as dotted out on the bidirectional buffer on the clock side. So I'm questioning, how do you do clock stretching if that's the case, if it's disabled or whatever it is in that circuit?
The question is, what does the dotted drawing mean?
Well, that PCA 9605 is probably bidirectional for each of its pin pairs, right? So could the dotted line mean that it exists but it's not used?
Okay, let's see here. I'm going to link the actual part data sheet, and they have a diagram there that might help.
Well, I found something on the internet, so it must be true here. Can I show it to you guys?
Yeah.
Yeah.
Yeah, the data sheet for the device doesn't have the SCL buffers dotted.
Anyway, this was, just to try to find out, what is is there a correct resistance value for I2C pull-up resistors? And they have a couple charts here, and looks like they're listing 200 picofarads. If that's what I'm assuming your line, or the load capacitance would be. And they have standard and fast modes. Fast plus, I don't even know what that is. I thought it was just 100 kilohertz and 400 kilohertz.
Yeah,
And
they
then
have
over
one, I
here-
think it's 1 gig now, or 1 meg.
Oh, is it?
too. Yeah, I think so.
Yeah.
So,
Okay. So I'm using the slow mode because I think there's less issues with, 100. There'd be less issues with 100 kilohertz versus 400 kilohertz.
Yeah.
And I don't know that it needs to be that fast. So
hey, Ray, can you link that?
can you see the link here?
Oh, that's
Yeah, I
in
can
the,
get it.
the data sheet for the PCA 9605 says that that it includes a unidirectional buffer for the clock signal and a bidirectional buffer for the data signal. Slave devices which employ clock stretching are therefore not supported. So I think, Pat, your interpretation of the dotted is correct, that it means it's not used. And you can't do clock stretching. It's in the second paragraph of the data sheet.
Yeah, and a lot of devices do clock stretching, which is the problem with Raspberry Pi. That's why
Yeah.
you slow down the communication speed to get things to work.
Anyway, looking at this chart, it looks like the max at 200 picofarads is around 6K, and the min, depending on the voltage that you're driving at, say maybe 3.3 is 1K. So you got a pretty big range there, 6K to 1K. So anyway,
That's kind of surprising because every board I've ever built, I put 4.7K resistors in there. Typically, my operating voltage is 3.3 volts. That chart is saying I should be going less than a K.
well, they said the minimum is
Minimum.
a K, depending on which voltage you're running at. And then the maximum for a 200 picofarad, capacitive load is 6K. So
Okay. So I could probably get away with much smaller pull-up resistance in most of my cases.
or higher resistance, you mean? Or
Well,
you would go lower? Yeah.
Lower is going to be less noise, more noise immune, for sure.
Mm,
so you're saying the design strategy is to go with as high as a resistance on that as possible. So 4.7K is probably still pretty good.
hmm
Okay.
And my understanding is the opposite of that. You want to make that load as tough as you can drive, so it doesn't move around, right? So
Because it'll
load that's
absorb all this reflected energy.
Yeah.
That-
right, less reflected energy, less movement.
So you said
Lower
your
impedance.
strategy is to go with low pull-up resistance as possible?
Yep.
The thing is, if you make it too low, then the source won't have enough oomph to get it up over the logic threshold.
Right.
If you make it
Yeah.
Too low, you won't. Not only will you not have any noise, you won't have any signal.
Yeah.
Right.
Yeah.
Right. I mean, yeah, you make it zero, right? Just-
Yeah.
But you make it too high, and then you create this transmission line termination that's just like a big mirror. And then as soon as that reflected signal heads back, that's just created a spike that the chip at the slave doesn't understand transmission lines. It just sees voltage. So this RF effect creates a spike, and the slave says, "Oh, I see another signal."
And an
So I
outside
guess-
energy source can swamp the higher resistor, whereas it has a harder time swamping the lower resistor value. So
That's I guess for future projects, I'll consider like a 2.2K pull-up resistor.
Yeah.
I
Give it a
guess you
shot
don't.
and see if you get lower bit error rate.
Yeah. Yeah, it'd be kind of interesting. Yeah, I like to see what your logic levels are, and if you're getting these really, slow rises that, like it's charging in, an RC circuit, basically a charge and a ramp up and a ramp down versus a nice, sharp rise and sharp fall.
And that's the cool part to me about using the scope. Why I'm so interested to see what Doug can find out, because the bit error rate is going to tell you in practice, if you made a difference. But with the scope, like Doug's got, you can see. I mean, are you centering the design in the specs or not?
Right.
Yeah. Yeah. The thing is, I'll be quite honest, Carl. If it works, maybe
Well,
not.
okay.
I mean, after the 12th of November, might go. When I go back in and say, "Why did I do it that way?" And all crying because something fell off in the middle of the race. After that part, then I'll be going in and saying, I wonder how this can be fixed. I definitely don't like the way I'm terminating them now. It just sucks, but hey, I got them to stick together. So we'll see how that works. We'll see how.
Well, I really appreciate this discussion. I've learned more than I ever expected to, but I too see tonight, actually. So this is good.
I've got a question to follow up with this. So what about using a level shifter? You buy the little level shifter chips, 3.3 to 5 volts. So I was just looking up the voltage level on the chips on that, on the little IGBTs or MOSFETs, whatever they are. And they'll handle up to 50 volts drain to source. Mm-hmm. So what if you're doing it along the length, let's say 2 feet or 3 feet in Doug's case, and you bump it up to 12 volts with a level shifter?
Well, I don't think your input then you would definitely have to have some sort of buffer between it and your
well, you put a level shifter at both ends. So you can level shift it, let's say at the Raspberry Pi from 3 volts to 12 volts.
Hey, that's actually
and then from 12 volts back down to 5 or 3, whatever.
So Pat, I got an answer for you.
Okay.
So you got I think two things, or you got several things working together here. So the going to a bigger voltage gives you the chance to better have a wider voltage range between thresholds, right?
Helps with noise.
So it can, right? Because it gives a bigger margin, but it also gives, if you think of capacitance in dV/dt, it also means it's going to take more time. Whatever the capacitance is in the circuit, it's going to take more time to get from this voltage to that voltage. So by definition, it's going to slow you down. But by having a bigger voltage, what it can do is, let's say you've got radiated noise coupling into your signal line, right? You don't have twisted pair. You just have these two little, Dean's pin connected Arduino wires. So you have this loop area in between them. And then you got some magnetic field going through, alternating, and that's going to couple a signal in. Okay. So if you use a bigger voltage, then that means that whatever that ambient signal is going through that loop area, it's got to be a bigger signal to create enough signal to throw you over the voltage signal and thresholds and create noise. You follow what I'm saying?
Yep.
So for those kinds of radiated susceptibilities, that bigger voltage thing is going to help, but it'll slow down your maximum clock rate. But think about it the other way, right? If we talk about the effects we were talking about earlier, where it's transmission lines, and you're launching a signal down a transmission line, and it's not, or it isn't terminated at the other end, so it's going to reflect. Well, is it really going to matter if you send a 5 volt signal or a 12 volt? Because if it's not terminated right, the same ratio is going to VSWR, same ratio is going to bounce right back. So it's not going to help the transmission line problem, but I think it would help. By that logic, it should help, like radiated or external susceptibility.
That's what I was wondering. For the external susceptibility, you're going by your motors, you're going by, servo motors, things that are moving as your robot turns along.
Yeah.
What could that possibly help?
And I think I think for all of these, I mean, that's why it's in a way it's too bad Scott's not here because I don't know much about CAN bus, but he uses it pretty exclusively in his robots, even though they're not all that big necessarily. But he's familiar with CAN bus from his day job, and to my understanding, the CAN bus, I think at the physical layer it's a current signal. It's a differential current signal, or it's like I said, it's a current being pushed through the wire, not a voltage level signal. So it's
I thought
inherently
CAN
less.
bus was a differential voltage.
Is it? I'll believe it. Okay.
Hey, can I show a little something?
Yeah.
I just put it in a chat, but I really think that it's kind of cool.
Good.
And I think it's only 2 minutes. If I can get to it.
Kareem, thanks for the link on the active terminator. Okay, this guy's going to show me up. Okay, good. No audio though, Doug.
Anybody getting sound? I'm not getting sound.
Okay, well, all
I
right.
can read the text though, so.
Okay.
Oh,
Oh, this is going to be a problem since we're required to hear the noise.
ding,
Oh, yeah,
ding, ding,
hearing-
ding, 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 ding. Anyway, if you can't hear it, I think the best thing to do is to pull it up yourself when you can. It's actually pretty cool.
I saw a demo that they had 1 meter long loop and just a 1 kilohertz signal, and it was cut in half with just a 1 meter. And then when they put everything together, it was a perfect signal at the end. But when they separated the wires, 1 meter there, 1 meter back, cut the signal in half at 1 kilohertz. And it was going into, I believe, a 1K resistor. It was not I mean, it was kind of like a weird, you wouldn't even think that could happen, right? But then they twisted the wires and then all the signal got there. So that was just like to convince you on how to lay out circuit boards. That's what the class was about.
Mm-hmm.
The ground plane is needed, you know.
Mm-hmm.
I like, there was a local, I think it was Channel 11. He was commenting about the, whatever, I guess it was a spacecraft, the whole spacecraft that was shot at an asteroid to see if it would change its orbit. And he was saying, well, they can shoot at asteroids to see if they can change their orbit, but I still can't get decent cell service where I live. I think it's kind of the analogy is, how do you terminate the I²C? I don't know.
Right. Keep your wires close together.
This has been a very enlightening discussion about I²C, and the data sheet on that PCA 9605 tells how they do the bidirectional buffer. I'd always wondered how you make an open circuit driver that will drive in each direction. And essentially they have a lock voltage and each side is looking at its input voltage. And when it drops, it says, okay, I'm grabbing it and driving it in that direction. And it'll hold it, it'll lock it in that direction until the voltage rises, at which be above the lock voltage, at which point it would allow the other side to drive low and thereby lock it in the other direction. So that's how they kind of dynamically change its direction. I always wondered how they did that.
Look at us figuring this stuff out real time. How about that?
Learning a lot.
This is a pretty long discussion. It's almost like our PID control loop discussions.
Oh boy.
It's getting there. Yeah. Second level, you know. Be like-
Add I2C to the list. Well, is that a segue to something else? John, you got another topic for us?
Did you have anybody else in line?
Actually, I have something if you want to see.
Both
Unfortunately, the
times.
person I was hoping online isn't, but in any case, I'll show you this. Yeah, there we are. Share. So, regard to balancing robots, I
the
found
inverted
this.
pendulum.
So it's not a robot per se, but he does go into the fact that actually it's pretty long.
Will it
winded,
swing it up?
Yeah.
Or do you have to?
So you'll.
Hey folks, welcome to this new video. So in this video, I'm going to talk a little bit about this new machine that I made here. So what is this thing? It is a inverted pendulum balancing rotor. So talk a little bit about how it works. Do a little bit. So first it is a little pendulum here. You can see it's free spinning on the shaft in the middle. And machine's turned off right now, so it's just a regular little spinning pendulum. I can turn it up, let it go, and it just swings, and will eventually settle back down to its steady state at the bottom. So, I turn it on. So turn the pattern on. Okay, so bring it up to the very top. And there we go. Ah, no better. Yep. Oh, that's an interesting angle. Look at that.
So what's the point of this, John? Is it just to keep it balanced?
Yeah, in this case, they keep to balance. But the key is he goes into the finer details of how he keeps it balanced, which is why, remember, so I'll move it
Yeah.
along.
It may have been 40 years ago now. Analog Devices had one of the electronic shows. They had an inverted pendulum like that. It would actually swing it, from, to the inverted position and hold it. So,
Right.
yeah.
But he talks very good about and simplifies the mechanics of it. So that's why, because remember, Harold the other week was wondering about feedback and all that. So he talks about that in here.
I don't know about you, but I'm barely getting any audio.
Mm.
Okay, I'll see if I can crank up volume. I have it at max. There.
So that's zero position.
Is anybody else hearing much of anything?
No.
Really?
Not hearing it now.
But looks like a good reference.
So yeah, it's a good reference. So I would recommend. I would recommend it. So yeah, next week, remind if he's online to bring that up to him again.
For Harold, yeah.
Yeah, for Harold.
Because I know David Anderson's talked about this before too, but
So basically, he talks about the servant feedback loop and that. See if I can move it a little along the line.
Actually, with the I squared C stuff, if like in my case, I have um, the GPS unit, the color sensor, and the BNO 055 all on the I squared C bus. And each of them have terminations that I haven't messed with. It's running at 100 kilohertz. I haven't looked at any waveforms. Knock on wood, it's still working. So,
Yeah. They'll probably still work. Yeah.
yeah. So,
Good enough.
and Adafruit, I think, chose, 2.2K for the BNO 055. And I think the SparkFun unit has 10K pull-ups on it. So, and I don't remember what the color sensor has on it, but there's 3 separate sets of pull-up resistors along the I squared C bus, which
Means they're in parallel.
yeah,
Yeah.
Yeah, so then you got to do the parallel resistor game and figure out what's the total load to see if the source can manage it.
Yep.
Because I want to say, you know, that they tell you that it's better to just use one pair, you know, not to have everybody set up. And some of the sensors have them where you can disconnect them or put them in. But yeah, I'm like you, Ray. I just stick them on there and see if it works.
yeah.
We'll see how it
Tell you
goes.
though, just from the thinking through it, if like let's say that you have this one long line and you have all these sensors along the middle of it,
Yeah.
then if the thing we've talked about with the transmission line is the right idea, then you would want the termination at the end of the line.
Yeah. Or
But if
maybe
you have-
the,
If you
the
have a
lowest
line
resistance termination at the end of the line.
yeah, well, just one. You'd only need one at the end because you're going to launch the signal down the end. Let's say these little taps where the extra sensors are, they're not.
Don't affect
not
it.
yeah, they got a short LC that they're adding, so they're not adding much LC and basically no resistance. So basically, you terminate at the end, and then you're just making a tap in the middle. Whereas if you have a line down here and then you split off a Y that's kind of length there and length there, now you've got a couple different transmission lines. So you'd want a termination at each end.
Actually, mine's like a split. It goes to the GPS unit first, and then it Ys to the BNO 055 and the color sensor. So who knows what I'm doing? My waveforms may look like crap, but you know,
It works.
it's
So
it's still working.
you're doing it at 400,
No, 100.
100. Okay.
Yeah, kilohertz. Yeah. Yeah, not unless you really need it. I mean, I higher frequencies, I think, would just complicate things. You'd get,
Yeah.
you know.
Yeah, I'm not sure I think what is your BNO 55 standard setting? Is it 100K?
100, yeah.
Yeah, okay, so that's what you're doing. That's the one I'm
Yeah.
using.
Yeah. And even in Adafruit's code, she had she said optionally you can run it at 400 kilohertz. And here's, wire, the statement basically that sets up the, I squared C to be that. So
I like that link Kareem put in for those terminators. That was definitely been a lot easier than what I tried to do. So we'll see. If mine doesn't work, looks like I'm going to go out to get some terminators.
So those were active terminators, though?
No. Well, I wasn't looking so much at. He did mention active terminators, and that's a possibility to look at. But I was also looking at how he terminated the Ethernet line. See, because on mine I hacked that all together, and he just used a standard connector, the standard connector, and put it on. That would be a lot cleaner, I think, than what I did. So I was just saying that's might be worth picking up a couple of those. I guess they're female connectors. So when you take your positive one off of your line, stick it in, and it breaks it out. So it might be nice. We'll see what works. But it also gives me hope if it doesn't work, I can probably get those terminators, the active terminators, and see if that helps. Because they definitely say they're running it through like 3 meters of line or something like that.
I have a silly question now.
Okay.
So I've not used, well, I have used, but I've not used an accelerometer for double integration for speed. I used one in a different application, but I've not used one for that purpose. Does it work? This is my question. Does it work to use the accelerometer, let's say, to start from 0 and build it up to a certain speed? I've got 3 robots. I want them all to go to the same speed. They have 3 different drives completely. So I'm trying to like marry them together. So I wasn't planning to put encoders in. I was hoping to just use this. But then there's something else that complicates, and that is they may be off center. You know, they may be not level. But I know where they can be re-zeroed and start off again. Is that a possible way to do it, and does it work? I'm not trying to get accurate wheel encoder resolution for distance. I'm trying to just get to a velocity. So I like to say I want to go to this speed, you know, where they're all running about the same speed. Does it work for that? Would it work?
Does not work for that.
Does not.
Yeah, I was going to say is,
Not in practicality. It won't. I mean, technically you can get velocity from the acceleration, but accelerometers are very, very noisy. If you're talking about these MEMS sensors, yeah, you'll get very inaccurate results very quickly.
Okay. So I've seen a robot called Ringo, and that robot, they use only the accelerometer, and it looks cool, but it's on a very flat surface, and it does work, but then I read a whole bunch of stuff where it say it doesn't work, right? So I'm hearing it doesn't work. Has anybody tried it? You know, I mean,
No,
I appreciate that.
yeah.
Nope.
My team has tried it without success.
Yeah, no.
I cannot say that that's an indication of whether somebody else could be successful, but it looked pretty dim to me.
Okay, all right.
And I want to say Dave Anderson also, they ran experiments like that and came to the same conclusion, if I remember right. And I've always heard it is a bad idea.
Okay.
And where I've read it or anything, it's
So-
you know,
What do you use then the Bosch 055 for? What are you using it for? I mean, that's a real question then, right? So I'm trying to understand.
usually, okay, well, you can get heading, that's for sure.
Yep.
Okay. I don't think you really can't, you know, that's what most of us are trying to do is get a real accurate heading.
Heading, okay.
And attitude, and basically your attitude in 3 dimensions is
Yeah, yeah.
our heading. Yeah.
I used it on a rocket launcher, shoulder launched rocket launcher, to set the crosshairs, and I'm not kidding. And I did the math and all that for launching a missile, and it would put the crosshair in the right spot because it knew that how you were holding it, right? It was pretty cool. It was an active crosshair and laser rangefinder mixed together. So you had the crosshair in the right spot to where this dumb rocket would hit, right?
Mhm.
And so it's kind of a cool thing. But it seemed like they were pretty good. But they
That's
wildly-
different. That's different. That's not velocity. That's heading,
That's
right?
heading.
So the angles from the gyros
Right.
are going to be more stable, and especially not so much heading, but your azimuth, your
Roll and
your
pitch.
your roll and pitch are going to be more accurate because they are stabilized by the known gravity reference from the accelerometers.
Right.
From Earth.
Okay. All right. So wheel encoders are a must of some sort. Right.
There are other ways to measure speed, but that's probably going to be the first place you want to go experimentally.
Okay. That was my only question.
For the things we do, right? So
What?
it's so application dependent, right?
Well, I don't know. I mean, I just thought, well, if it's a short period of time, I'm just trying to, in 1 second, I want to go to this speed. Will they get close? You know, I mean, that maybe not, right? So that's a servo loop over a short period of time. But if I don't have to try it because it doesn't work, then I won't even do it. So,
Yeah.
all right. Thank you, guys. That was my silly question.
Cool. No, good
All
question.
right. So, Carl was prompting me there. If y'all were here last week, I sent Doug what I call my Raspberry Pi headless control board, which is this little board I put together here, had manufactured by Oshpark. It's really just a simple board. It's just 3 LEDs with an individual input for each one of the LEDs, 2 push button switches and 2 dip switches. That's all it really is. But I've provided Doug with a Python script that you can use this board to control your Raspberry Pi application. If you wanted to run headless, you didn't want to have a shell script, you didn't want to remote in, you could just push the buttons, start your application running, push the button again, your application stops, and then you can push one button that will actually do a graceful shutdown on your Raspberry Pi using that script. So, and the LEDs flash according to whatever's happening. The green LED flashes as long as the run headless script is running to tell you that the Pi hasn't frozen up. The yellow LED flashes when your application is running, or when it's not running, it doesn't flash. And then the recent change that I made to the script that Doug was commenting on was the script monitors the process that you use to launch your application. And if that process dies for any reason, instead of just a flashing yellow LED, it's flashing yellow and red. So as long as Doug thinks there's no major improvements that need to be made, I was willing to manufacture, let's say, 3 more and make them available to club members who would like one. If there's more than 3 people who want them, then we'll have a drawing. Sound good?
Sounds good. Or maybe even Carl, we might. Well, what's the interest for? I mean, if you're going to use a Raspberry Pi on a robot, you almost got to have something like this so you can shut it down gracefully without it just dying.
I think most people here for their robots have some sort of wireless control. The only thing they would get out of this is an application that would allow you, well, with the wireless control, you can also initiate a shutdown there if you're running a shell script.
But if let's say you're out on Robo Columbus, okay, you're going to probably, you might not be in a place where you have Wi-Fi, but let's say you have something locally like an ESP32 or something going on. You still, unless you got I don't know if Ray's little handheld thing has a button that he can control, send messages to the thing or not, but
yeah, I don't, but it is a touch screen on the front. So
yeah. So what I'm trying to get at is just the idea, and why I'm really was interested in it, John, and what I see the real value. Okay, so like when I start up the robot, I'm going to have to change directories. I'm going to have to kick off a Python program to get it to start looking at the OD light. All right. So it's in there. Instead of me trying to do that before I start, I can just push this button, plug it in, and it will automatically run that. And I'll get an indication that, yes, everything's good. And I'm out here in the field now. I'm not anywhere near my computer or anything. And then when I get finished with the run, I can just walk up to it and hit kill, and it kills it all. So I think that's got a lot of value. And I mean, maybe other people don't see that as, they see other ways of handling it, but I really appreciate it. So.
Well, let me know. We'll see what we can do.
Well, quick show of hands for those people online now. Do we have 3 for John? Oh my goodness. So I would ask you, John, but the trouble is I have this, I went on a shopping spree and I I went and got the Pimaroni on-off shim. I have several copies of this. And basically it's not as capable as yours, but it comes with a script. What it does is you can actually mount this board. It's thin enough that you can cut the header away from the Pi, and you can mount this board on top of the header pins, and you can still put other things on top and use the header pins. And then this has so you would then power the board through here, and then this button, I think it must have a similar function as your buttons, but when you first apply power, nothing happens. When you push the button, it powers up. And then if you want to do a graceful shutdown, you push the button again, and the script in the Pi does a graceful shutdown.
Mm-hmm.
So I have a handful of these, and because of that, I'm not going to be asking you in this round, but because I haven't used these yet. But I like yours, John, in the way you got multiple LEDs, not just one, and you've got the dip switch and the two buttons, so that gives you some options that you don't have with this.
Right.
Yeah, and this is, and in truth, this is just a generic board. It's just 3 LEDs,
Yeah,
2 push button switches, and 2 dip switches. You can actually use it for anything.
for anything. So John,
But nobody's
are you,
interested. So
well, are you trying to gather enough interest before a build date, or would this be a special build that you do?
I'm sorry, what?
Were you gonna go and make a run of boards in order anyhow, or are you thinking of doing a special run just if there's interest?
I was actually going to make a few more boards for myself, so I did another run. I'm just saying, if anybody wanted one of them, yeah, I can send it to them.
Okay. You want to take an order? If you wanted to take an order, we could put it out on the list or something. But
So I'm going to put pies in my robots. That's 3 pies. But I don't know. I haven't got as far as you are, right? I mean, I haven't got as far as knowing how I'm going to power them up or power them down. I was hoping they would boot up into their program is my goal, but I have no idea if that's possible or not. So, but I believe it is.
That's the Achilles heel of the Raspberry Pi is the micro SD cards. If you yank power while they're being written to, they can occasionally corrupt to the point where you can't even use them anymore.
Right. As long as you don't yank power, you should be okay. Or, that's just my gut saying that. But I don't know that,
Yes, as far as the kill switch part of that, I mean, if you can run faster than your robot, you're okay, I think, because you can get to it. But
Oh, I see.
Bob, the
if
other
your robot
alternative,
is faster than you, then boy.
you may not have been here for the earlier discussion on that. The other alternative on Raspberry Pi is the Raspberry Pi. Most of them have a couple of extra pins that are not populated. They're not on the 40 pin row. They're off to the side a little bit. Basically, if you just short those 2 pins together, that's the run signal to the processor, the Raspberry Pi board. What kills the micro SD card is if you pull power, you're pulling power to the processor and the micro SD card at the same time. So what happens is when the processor writes to the SD card, it's got some internal circuitry that takes some time to actually flash that into memory. If that process is interrupted, as in yanking the power on the SD card, that's what kills it. But in the case of this kill switch that I use, that I tie to those 2 pins, if you halt the processor, that doesn't kill power to the micro SD card. So whatever write was in progress, when you halt the processor, still happens. So it's a two-step process. You short the pins with a switch, and then you power down. And that I've never had an micro SD card corrupted on a Pi where I did that.
I see.
I actually, I'm running Octopi, on my Octoprint on a Raspberry Pi, and I was getting low voltage warning. So I was changing my, I was putting it in another Pi, the SD card, and I did it while it fired up. I pulled the SD card while the thing was fired up. And I had remembered that you're not supposed to do that. But luckily, I didn't fry anything or burn any or corrupt the data. So I got real lucky. So I didn't mess anything up pulling that SD card out while it fired up. So.
Right.
Yeah, that's also a common problem with Raspberry Pis. They're always complaining about low voltage. They're really.
I know.
And you just have to have a really good power supply and a very short cable with low.
You buy them power supplies that are made for Raspberry Pis on Amazon, and they still come up with low voltage. And but this power supply I actually checked on another Raspberry Pi, and it did the same thing on another Raspberry Pi today. So I went ahead and chunked that power supply. I'm not gonna fool with it. And I bought a new one today, so we'll see how that goes. But yeah, I bought three of those power supplies off of Amazon that give me that low voltage warning. They probably work for Arduino or whatever, but I
I
don't
think
know.
it's largely just a nuisance.
They're just cheap.
Does anybody know in those cases, if it's really actually a problem?
I
Yeah.
believe there's a bug in the Raspberry Pi 3B Plus, where even if it's powered with a correct power supply, a bug in the firmware will tell you that you've got low voltage.
I've actually printed with it saying that, on that Octoprint. So I've done it, but I was like, I don't know, it messed up today. My printer did. So I thought maybe it was that low voltage, but it was actually a clogged tip. So anyway, I went ahead and bought a new one. But yeah, I've had that problem several times. So, but I was yanking the SD card out while it was running. While it was turned on, and I forgot. Oh, you're not supposed to do that. But I did it. So apparently, it didn't hurt nothing.
So I heard that the Raspberry Pi 4 was touchier about its voltage than the prior one. And I think the Pi 4 takes 5.2 volts, and the earlier ones only take 5.1. So some of those Raspberry Pi 3 power things won't work on the 4. That's what I heard.
The 4 requires a lot more current.
Yeah.
Your issue.
I know on my telepresence robot, I'm giving it 5.1. It's giving me the low voltage warning. And on my new one, when I finish building it, I'll do 5.2, and we'll see if it works right or not. I bought a new step-down power converter that puts out 5.2.
5.1 volt, 3 amps. Yeah.
Yeah. See, will that work on the Pi 4?
Ray, did you buy that at Tanner's?
Huh.
You're muted, Ray.
Yeah, no, I got this at Micro Center, but that's what they recommended for the 4 was, and that says 5.1 at 3 amps, 5.1 volts at 3 amps. I don't know if you can read that or not.
Yep.
The cable on it is fairly long. It's like 1.5 meters, but they say it's 18 gauge. So don't know what the actual gauge on other power supplies is. But with a fair amount of current, small wire, you can get, a little bit of a voltage drop there.
You said 18 gauge
That's what this said. Yeah.
AWG.
Yep.
That's a huge wire.
18. Yeah, it's pretty
18
thin.
is huge.
Like 10 or 12. The lower the gauge, like double
The
Oz
larger
is
the
the end of your
wire.
finger.
I mean, I was trying to find some wires here.
16 gauge is like 15 amp cable.
Yeah, I'm
18 is
using
like- yeah.
I'm an electrician, so large is until you get into the MCM sizes.
Yeah.
I'll put my finger up here for size comparison.
When you get a 750 MCM, you're getting to a big cable.
That's 22 right there.
Yep.
So 16 is a lot bigger than that.
Well, this said 18 though.
18
That's why
still.
18 is a lot bigger than that.
Yep. Anyway, that's what it said it had in it. But
That's good.
oh yeah.
I mean, the larger the larger the gauge, the less resistance.
Yeah, when I was charging my battery, I made a battery cable, and the one that I had on previous to this one, I had about a half a volt drop on each side, only at like between 1.5 and 2 amps on fairly good sized wire, probably 16 gauge, maybe even 14 gauge. So I was surprised at that. I was looking at what the voltmeter on the power supply said, and then what it said on my actual voltmeter. So, but now that I have this, it's much less. It's in the less than 100 millivolts. But these are, I'm not certain what gauge, maybe 10 American wire gauge. Pretty hefty, and the banana plugs have a lot of surface area on the where they make contact. So
I don't know if you've ever dismantled a USB cable, but the typical USB cable, the wires are tiny, 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 like 28 gauge or maybe even greater.
yeah, I thought USB-C had much greater current carrying capability, because that's what it says in the bottom there. It's a USB-C cable. So haven't had any brownouts. I've had the little temp sensor come on, but I put on my Raspberry Pi 4, I made a little fan mount for it, and it keeps it cool. So that's a Raspberry Pi 4 in there.
Yeah, I read recently that some people are saying that unless you're overclocking, you really don't, even on a Raspberry Pi 4, you really don't need a cooling fan unless it's in some kind of enclosure.
I'm not sure about that, John.
And I think we just lost Ray.
Pushing it
Oh,
hard with some OpenCV stuff,
Yeah. There's a wonderful website. Let me see if I can find it. It talks about Pi 4 enclosures.
Are we talking about plastic ones or metal ones that are?
Doesn't matter. It's got them all.
Oh. Yeah, some of them, if you can get enough, a big enough heat sink, and it makes good contact with the chips, then probably don't need a fan.
you do have to be careful with metal enclosures because metal enclosures will interfere with your Wi-Fi if you need Wi-Fi. Not just metal enclosures. I've actually had recent experience with I had a Pi 2.0, Pi 02W, and I got a metal heat sink that I put on top of the board, and it definitely dropped my Wi-Fi performance.
Yeah.
So what happened to Carl?
I'm just soaking it in. You guys are carrying the conversation.
Okay, when you're not talking, your video disappears. Your video gets hidden.
Oh yeah, the active people get to claim the sidebar there. I'm
They
still
get
here,
all
just
the bandwidth,
nothing.
don't they?
So, BattleBots. I hear that Makerspace has 3 different BattleBot teams work out of there.
Have you checked into them?
Well, not yet, but look at this thing my wife gave me. I'm gonna.
Because just before COVID, or a year before COVID, there was I saw one of the teams, and it was, I mean, they were pretty serious. They had been working on sponsorships, so they were plowing like $40,000 and $50,000 worth of gear into theirs.
Oh yeah, you see this picture my wife gave me?
Yeah.
3 different BattleBots out of Dallas Makerspace.
Yep.
Dang. Where do they get all their funding?
I don't know.
Sponsors, I think, of some kind.
I know, man.
A lot of them have sponsors.
Yeah.
Yeah, they had a watch party in August that I missed. And stop sharing. Go back to what I was doing.
Yeah, I've been watching a lot of those competitions on YouTube recently, and it's amazing to see a 200-pound robot being thrown 15 feet in the air from a
I know.
from a hit.
And then keep moving.
Yeah, and land and keep running.
My robot won't do that. But those
Yeah,
are some expensive robots.
If you get a
Yeah,
chance,
if that did that to my robot, the wires would fall out of my breadboards.
I wouldn't mind running into them guys sometime when they're there and just kind of seeing what they're actually got working on. They look like
it's worth it. Like I said, I saw them when they had it. They were partway through construction, so it was work in progress on the bench. And you want to talk about beefy, durable. I mean, put some serious thought, not just money, but serious thought into the design and construction. It's pretty cool. So if you can, let us know if you find information on that, because I don't know when they meet or anything.
My eye on it.
Yeah.
I thought there was also a group that was doing smaller BattleBots, not the, several $1,000 variety, but just smaller BattleBots, kind of like the things that, the size of stuff that we would do.
Mike's Hobby Shop used to have an arena for those.
For
but
the
they
smaller
closed
ones?
down a few years before Tanner's when I-35 expanded.
Yep.
Yeah, there's more than just the TV BattleBots. They apparently have robot battle things all over the place, and that's just the premier ones. My robots aren't ready. I just am always interested in how they go about doing it. And they're right there apparently in our makerspace if we ever run into them. I know the group that was in that picture had a watch party in August of this year. So we just missed it. I'm gonna try to keep my eyes open.
Yeah, but if you check Talk or Discord, we could figure that out.
Yeah. I'm not very good at keeping up with all that social media stuff.
Life gets in the way.
I know. As long as I've got the speaker, I'll quickly mention that I've been working for the last couple of weeks on this iRobot that Doug gave me, and I am just having trouble getting my Raspberry Pi to talk to it. But I've seen recently an article on getting an Arduino to talk to it, so I'm still thinking about doing that. But I'm going to take a break from it. If Doug doesn't shoot me, he may have missiles heading my way. But I really need to finish my production version of this telepresence robot so I can provide that information to the people in Seattle. So I'm going to take a break from iRobot and get back to it once I finish my telepresence.
It's yours to do with whatever you want to do.
It's still been fun.
Yeah. Yeah.
it's hard to find documentation on the version 1 because everything's version 2 or beyond now.
Yeah, but you still should be able to find version 1 information. Anyway, you can just look up using Roomba as a robot, and a lot of that applies to the Create.
Yeah,
Create
the difficulty was that the version 1 was a kind of a direct control. You had a serial connection, and starting with 2, they got into the raw stuff.
Yeah.
So a lot of the stuff you find is raw stuff. It doesn't apply.
But a lot, you got to remember the first Turtle bots that was done by, what is it, Willow Garage, were
Roombas.
basically Creates and Roombas.
Right.
So now,
I haven't given up.
Yeah.
I don't have it on this screen, but I've got a really interesting article on my other screen, which rather than present, I'll just point. And this one has what appears to be a very good explanation of how they're connecting that Arduino, and this is exactly the program and all that stuff. So I'm going to try that, but I'm going to complete my telepresence first.
Yeah. Originally, they had a early Arduino. Otherwise, we always talk about a 328P, but before there was 328Ps, Arduino actually used a 168. And the Create had an option to buy a little block or something that had a 168 in it that it used to communicate. It was real nice. It had plugs that you didn't have to make anything. You just used it. But
pointing at that, I think that green thing that you had in here is what you're talking about.
Could be.
I think that's what I've heard about it.
Okay, so that's the 160. That's a 168, or if that's what it is, that's what you already got something that's like an Arduino.
Right.
Probably 99% of Arduino code would work on that.
Right.
If you had the bootloader.
On the side here, you can see this USB cable I got because it's got a connector that would work on the Pi, but I just couldn't get any of the Pi interface commands to work. It says send it this, this, and this, and I did it, and it said, well, I don't care. I'm not doing nothing. So
did you get a battery for it? You need to get
the battery's charged, and it'll move around.
Oh, wow.
Whatever program is in it at this point. So it is functional. It just wasn't responding to my commands. I think it was an interfacing option I was having trouble with.
Okay.
But I'll try this Arduino thing. I have pretty high hopes for it, but I need to spend my time on this other thing and get it finished. I need to finish one thing before I start another.
I know what you mean. It's hard to keep focused, isn't it?
It's a bad habit.
Yeah.
That's why I'm not in Robo Magellan, even though I was pretty interested in it. I need to focus on what I'm doing first.
Yeah.
I'm done.
Doug, I could one of the experiments I could try with this radar distance sensor is to put a tinfoil hat on the cone and see if it reflects.
Yeah.
They always come in useful, the tinfoil hats,
Yeah. Well, I'm real interested in that because, that always seemed like that ought to work. You know what I mean? But
yeah.
It was just, I guess I wanted something that was a little more turnkey. Sounds like they're approaching that now. I mean, you have a program that looked pretty reasonably easy. I mean, you know what I mean? It didn't look like.
Yeah, and I probably could have done it with some of the string functions, but I don't really use string functions that often, and so I kind of brute forced it and said, okay, I want to see this character in this part of the string, and the rest of the string is, I can convert to data pretty easy.
Yeah.
Or an integer.
I need to neaten up my workspace here. I've got a GPS unit I keep wanting to practice with too, but it's laying around here somewhere. I don't even know where it is now. It used to be right there.
I know what you mean.
How many projects?
Yeah. Well, I don't know if you saw that. I mentioned earlier that I put a ground plane underneath on my antenna for my GPS.
Right.
So I got that all working. So let me show you that real quick. Because I didn't want to have any big plates of steel on my robot for the battery, for the compass. So I just bought this one 6-inch thing of aluminum. I could have cut it out, but it was just easier to buy. And when I took this out of its little black case, and then I desoldered this bottom part, which is like a shield for the electronics. And then what that allowed me, it gave me access to where the cable was. And I was able to shorten the cable length from whatever it was, 40 inches to what I needed. And so to bring it back, I didn't want to punch a hole in this plate, not because you couldn't, I just didn't want to do it. So what I did is I put 4 little standoffs, and so I punched 4 holes in the plate and just put solder on them, and then I soldered that aluminum plate, aluminum box back to the steel box back to these guys, the shield, and then I pushed down hard on the top and then soldered the corners to get it concealed, and it came out really well. I mean, it really just working great on U Center. So that's cool.
So you before and after, you have before and after comparisons that show that it was a real big improvement when you did that?
Well, I didn't on this because I had to have an antenna. Okay. Otherwise, this particular GPS unit doesn't have a built-in antenna. So I had to attach an antenna. Let me put it this way. It's no worse than it was before. Okay. And let's see, it's been running for a while. Let me see what I got here.
And you got rid of the strong magnet.
And I got rid of the magnet. Yeah.
Yeah. In essence, Doug, you've got kind of a small tinfoil hat on that thing. You know, it could shield your other signals underneath from, you know.
Yeah.
Works as a ground plane and as
why do they call it tin foil? It's aluminum foil.
Aluminum foil, yeah.
Okay, so see if I can. For some reason, I'm having trouble with my screen, but let me show you this.
Maybe it's just an anachronism. Maybe it used to be tin.
Okay, so this is what it's seeing right now.
It did used to be tin.
Yeah.
Tin cans too.
Yeah, so those are all of the satellites it's picking up. So it's getting some from China, some from the EU, some from Russia, and from the United States. And I want to say this is a 4.5 meter circle, and it's been running for hours. So you can see it does occasionally go out. So anyway, it's kind of cool. The antenna is antennaing. I guess that's what I'm really was looking for. But there's an interesting RTK GPS being put on Kickstarter with delivery in November. I don't know. Have you guys seen that? Yeah, let me see if I can get a link to that.
I think ST also announced a module, an RTK module that seemed pretty cheap.
Well, they've got this new U-Blot's come out with a new one, but it's not quite. If you read this, it sounds like they have made like an SE version of their 9 system, and otherwise it can't have as many. I don't think it has as many channels, and it doesn't have as many other thing. It doesn't have a refresh rate. I think the one I have is like 25 refreshes per minute, and it's like 5. Let's see what I can tell you that.
It's not like at least 1 per second.
can't remember. Anyway, it's it. I don't know. I'd have to. Don't let me. I'm kind of like a little bit concerned on it. Here it is.
It's probably the same silicon, and they're just feature crippling certain
Yeah, it
things
could
to
be.
create
I
a
agree
different
with you.
market segment. Yeah.
Yeah. So here's I found the link. Sorry for being so. Um, Kickstarter. It's for a pie, supposedly. Looked like a nice little setup. And if you just so you can see it. Here's what it. You guys seeing this? It says
Yeah.
TPG. Okay. So and I mean you can see they have two versions. They have one with a little screen on it and one without a little screen. This one looks like it, unless they have the battery on the backside, this one has a battery. I don't know. And the difference between the cost between these two didn't look like that much. This is specifically made to go on a Pi. So let's get to it. Okay, so and right now the pound is like going through the floor, and so their expensive one they're saying is 260 pounds. We're approximately 281 right now, but I thought I heard somewhere where the pound actually went below the dollar, but I don't know if that's true. And it's not clear to me. You need two, or at least you need a base station somewhere. So I would definitely look it over before so there it is set up on a Pi before I would spend that much money. Oh, there it is. It's the Z-F9P.
Yeah, that's the same one I use. Same
Oh, it
one
is.
I use. Yeah.
Okay. So anyway, that's cool. And I don't know. Is that a good price? $281, or is that pretty standard?
Well, I was just looking at SparkFun. They had a couple of RTK modules out there for 250.
Okay, so maybe it's not that big a deal. But anyway, there is one out there if you wanted one to fit on top of a Pi. So cool. Yeah, I'm really going to be real excited to see when Ray's because with his GPS now he should be within 2 centimeters or something, right? Ray, isn't that about what they say?
Yeah, for the one that I have, it's like 2 centimeters. It's
You're running right over
8.
cones, right? If the
well,
coordinates are accurate.
I kind of did it so it went like within a meter of the destination it stops.
Yeah, okay.
And then I can scan 180 degrees with the color sensor, and if I'm say behind the cone, I can rotate 180 and do another scan and look. So hopefully I'll be able to find the cone no matter where it ends up.
Mm-hmm. Well, one thing you might consider, you might not want to. Let's say you overshoot.
Yep.
Okay, so when you overshoot, you're facing away from the crowd of people.
Uh-huh.
If you do a 180-degree turn, you're going to be facing the crowd of people. I don't know if that color sensor, it might, otherwise, it might just pick up you might lose signal with all the people in the picture is what I'm getting at. You know,
So I
and
thought we had a rule: no orange socks or shoes.
no,
or
I mean, but
t-shirt.
if you actually on the one I have, I've looked at myself, you know, just kind of like, and it picks it. You know, I'm not saying you won't get a signal. I'm just saying it's not as sharp as it would be if you're looking at something that doesn't have
Yep.
people in it. So
We'll make sure Donald Trump isn't there. He's pretty orange.
yeah, and you might be like I say, I'm wearing a red shirt.
Yeah.
So, I mean, I wouldn't even thought about it, probably, you know, on the cones, but it would pick up more red than normal. So anyway, you might want to consider some where if you went past it, you know, you scan it. I don't know, just go to it. If it doesn't hit it, then you know you missed.
Yeah.
Or if it goes more than a certain distance. Because do you get a distance? No, you don't get a distance.
No, not with the color sensor.
Yeah.
I was thinking of adding either, you know, the radar sensor if it's going to work for cones, or one of the other LiDAR units, and then, you know, I could scan, look for orange, and then if I get, you know, a indication off the LiDAR that it's something close where it's orange, then most likely it's the cone.
Yeah,
you know?
yeah, that's a good strategy.
Yeah.
Yeah, like I said, I'm thinking I might put I'm not sure. I'm still considering what I'm going to use for obstacle avoidance and the final cone detection. I mean, well, I'm for the cone detection. I mean, I'm planning on using the Oak D light. That's for sure. But
so, and your model, you know, you feel pretty confident it's going to work in various lighting conditions. And
well, yeah. Plus, it, you know, it's not a universal cone detector in the sense because it's got a lot of biased images. Otherwise, I've gone out and took in my cone, you know, the cone that we use, and I put it in a lot of different situations. Well, so it's learning that type of cone. Do you know what I'm trying to say? Now I have pictures of other cones because I want it to be more broad, but for me to personally build up the data set, you know, I'm not going to go out and buy 10 different cones and do that. I've been thinking about maybe, you know, when you see a cone, you know, kicked off on the interstate, you know, over on the side, well, maybe move it down the road. Yeah.
Yeah. Most of them have reflective tape on them. So, you know, it's kind of like, oh,
yeah,
I just want your basic cone, no reflective tape.
Yeah.
So
I've been using little soccer cones and like I say, if you want it, you know, like you said, most of them have reflective tape. So you want to be able to detect one that's got reflective tape if you want a cone model.
Yeah.
All right. If you want a Robo Columbus model, maybe being biased is actually not a bad thing. So we'll see. We'll see when we get there.
Yeah, it used to be, it was about $1.50 for a pound.
Yeah, I know. That's what I was thinking, but I don't think it's that anymore. What is it?
Yeah. Almost parity here.
Yeah, is it? How much is it?
Ed said it was, I guess he doesn't include.
Oh, US. Yeah, there it is. It's $1.06.
$1.06. Oh, okay. Yeah.
Yeah, that's the lowest I've ever heard of it being.
Yeah. Yep.
Yeah. That's cool. Well, I mean, it'd be cool if you were going to England for something.
A lot better than 20 years ago when it was $1.60.
Yeah.
All right, guys. Well, where are we? Have we run its course, or are there any more items we should chat tonight?
Yeah.
All right. So it sounds like we're going to build some robots, try some I2C termination options, and come back next Tuesday.
Yeah, see what happens.
And see what happens. Stars. Let's see some rolling robots. All right, guys. Have a good night then. Take care.